Hello and good day, Geometry Blue on a Thursday. We are covering PO10, our final objective of the unit, which is on perimeter and area. Okay, and it's not your elementary perimeter area. Although we can just kind of start with some basic formulas, basic shapes, but think math packet perimeter area, where you kind of have to use these formulas and apply them in different figures, different situations. So its roots are in just, do you know the formula for the area of a trapezoid or a circle or whatever, but the application of it is going to be a little bit more geometry-ish. Okay, but we start with a square and a rectangle, both of the quadrilateral family. Rectangle first. What is the formula for the perimeter of a rectangle? How would you find it? Yes. Add up all the sides, right? So if you've got two sides of base and two sides of height, which is what makes it a rectangle, right? It's got those opposite sides that are congruent. Your perimeter is just going to be 2b plus 2h, which is a really fancy way to say add all the sides together, because you have two bases, two heights, you're adding them together, and that gives you the perimeter. What's the area of a rectangle? Area of a rectangle. Yes, Linnea.
How do you get it?
Yes.
And you multiply the base times the height.
Correct. Base times height. Okay?
No.
Probably the first shape that you ever learned. Okay? Base times height. For a square, the process and the formulas are actually the same, but because it's a square, and by definition, meaning all four sides are congruent, we would classify this as a regular quadrilateral, right? You can label all four sides B, which the perimeter is still going to be adding them all up, but how can we write this expression now that they're all the same, Luke?
4 times B.
4B. Okay, and for the area, base times height works just as well, but because they're all the same length, we can also think of it as
4b.
well, 4b is still going to be perimeter. What? Someone said it? Base squared, or b squared, right? Base times base, base times height. Okay, they're all the same. We're multiplying something times itself. All right? So, triangle. There we go. Okay. What's the formula for the perimeter of a triangle? Perimeter of a triangle, McKenna? So that's area, okay? Area is base times height divided by 2, or you can also write that as 1/2 times base times height. Multiplying by 1/2 divided by 2, it's the same thing there. How about perimeter? Or how would you find it? Maybe is a better way to ask that. Luke?
A plus B plus C.
Sure. Side 1 plus side 2 plus side 3 is kind of how it's written. If you label your sides A, B, and C, it's A plus B plus C. Basically the same thing as a rectangle or a square, just all those sides added up, right? But then we have the base and the height there for the area. The base of a figure is considered the horizontal side. Okay. The height of the figure is what, Nick? Not necessarily the center, but it's the vertical distance from the base to the top of the figure. Okay, which would be in this case that. Right? If you've got a triangle that looks more like this, perhaps. Okay, a lot of folks think that this diagonal side here is the height. Not the case, right? We have our horizontal side, our base is here, and the vertical line that connects the base to the top of the triangle actually isn't inside the triangle at all. We would have to imaginarily extend that base until we can get the vertical line going down to it, and that would be considered the height of the triangle. So triangles and other shapes with diagonal sides can be tricky because that does not represent the height. The height is always a vertical line that connects the base to the top of the figure. Sometimes it's outside the figure, okay? But that would represent the height. Good so far? Yes.
Will we be learning that?
You would have to be either given the height or more information. If I just gave you a triangle like I drew here, and I said the base is 7, find the height, you wouldn't be able to do it with the given information. So it's either going to be provided to you or you need just more stuff. But yeah.
For the triangle, the area is that base times height divided by 2 times a half, and then base height is
No, sorry, this was just a random marking. It's an or thing. You can either use base times height divided by 2 or 1/2 times base times height. Either formula does the same thing. Okay. Next up, we have a trapezoid. A trapezoid looks like this. Kind of the most commonly drawn trapezoid. Okay. It could also look like this, where only one side is diagonal. Okay. But what do we know about trapezoid? Perimeter is the same thing, all sides added together. So you've got side 1 plus side 2 plus side 3 plus side 4. Same thing as a square, rectangle, triangle, just all sides added up. But does anyone know the formula for the area of a trapezoid? The area of a trapezoid. Christopher, I guess?
So if you divide let's just say the top one, divide those into 3 shapes, and then you take the 2 triangles and then find the area. And then
So one option is to divide the shape into shapes you're familiar with. Chris is saying we can divide this trapezoid into 2 triangles with a rectangle in the middle. That would work. However, there is a formula that is specific to a trapezoid. Okay. The formula for the area of a trapezoid is 1/2 times the sum of the bases. We call them B1 and B2, which always makes you think of Bananas in Pajamas. Anyone grew up watching that show? Bananas in pajamas are, nope, okay, never mind. But B1 and B2 refer to the first base and the second base, because one of the characteristics of a trapezoid is that those horizontal segments, those bases, are different lengths. Because if they were the same length, I'll draw it over here, you don't have to draw it yourself, but if our 2 bases of a trapezoid were the same length, it'd be a rectangle or it'd be a square, right? Because you'd connect them, and you don't have a trapezoid, okay? So the characteristics of a trapezoid, the bases are different lengths. So the sum of the bases times 1/2 times the height, okay? 1/2 times the sum of your bases times the height. And again, that height has got to be a vertical line connecting your 2 bases. In our top example, the height would be here. In our bottom example, if this formed a right angle, which I tried to make it, but looks a little bit short, but that would be the height, right? But any vertical line connecting your top and bottom base. So, since it sounds like we're kind of unfamiliar with trapezoids, if I gave you a trapezoid that looked like this, made this 7, made this, looks like it'd be about 29, I suppose, and gave you a height of 8, to calculate the area, you would be taking 1/2 times the sum of the bases, so 17 plus 29 times 8. All right? 1/2 times the sum of the bases times the height, which, simplifying this a little bit, would equal 1/2 times 36 times 8. And who's got that calculated area?
I had it. Wait,
You had it, then cleared it?
wait, yeah, I got it, I think.
Evan,
144.
144. Second it.
I did not, wait, I don't know.
Yeah, I got 144.
I got 144. I lost it.
Okay. 144. Questions on trapezoids? All right. Last shape to talk about is a circle. Oof, not my best. And what's special about a circle is that it really doesn't have perimeter because it's not a polygon, right? For a circle, we call it circumference. What are the formulas? There are two of them that you could use. The formulas for the circumference of a circle. You two were super excited about this, so I'll let you each take one. Luke, give me one of them. 2 times pi times the radius, or pi r squared is for area.
I agree.
Diameter times pi. Okay? And the reason why both formulas work is that, if you recall, the radius of a circle is from the center to the edge, right? Or to the side. Not really called a side, but to the outside of the circle. The diameter is just double that. Okay? So if a diameter is made up of 2 radii, then either taking the value of the radius and doubling it and multiplying by pi, or just multiplying pi by the diameter, you'll get the same result. Okay, and that is the circumference of the circle, which is what makes pi such an interesting number, interesting value, is that the relationship between any circle, no matter how big or how small, the distance around is always approximately 3.14 times the diameter, always. Okay? And that number was discovered by humans a long time ago and became more accurate, more perfected, and now we have it out to 2 billion places, but still no end in sight. The area of a circle, someone already mentioned it, pi r squared. And you've got to be really, really careful because that formula for circumference and formula for area look awfully similar, but that 2 out here being part of the product versus squaring the radius, you get different values, except for one. What's the one value for the radius of a circle to where its circumference will equal its area? What's that? There is such a circle to where the value of the radius will equal its circumference. Obviously, different units. One's in units squared. One's because you've got length versus area. No. There is a radius length of a circle that, well, better than I drew, that will make the circumference equal to the area. Maybe I'll make that a test question. See if you can figure it out.
It's going to be like 0.00.
Well, if you think about what the formulas are, and think about what you're doing in each formula, then you can kind of work your way to it. But there is one value that makes the circumference equal to the area. Okay, any questions on those 4 shapes?
What is it?
Yeah.
Well, I could tell you, or you could explore, figure it out. Yeah?
You want us to use 3.14 or the pi button?
Either one. As long as you round to the nearest hundredth, whether you use 3.14 or the pi button doesn't matter to me. Okay. All right. Next page. Next page. So these are some basic questions to practice these. The formulas you wrote above can also be used to find unknown dimensions if the area or perimeter or circumference is known. Solve for the missing dimensions below. The question was asked earlier for kind of working on a triangle here. So we'll take this one. if we know the area is 66 square meters and our job is to find the height, right? Find that missing value h. The 66 square meters would refer to the shaded section there, so not the unshaded part of the triangle. So we got the area equals base times height divided by 2, and we know that the area equals 66. What else can we fill in here? What other information do we know? Noah,
The base.
which is what?
19, right? Wait, no, that's the other part. Is that other part outside of the triangle?
Good question. So this part here, this 7, refers to this distance, okay? But it's not part of the shaded
Okay,
triangle.
So
12. So the area of that shaded triangle is equal to 66, which was found by taking 12 times the height divided by 2, or base times height divided by 2. Luke?
I think the height might be 10.
Well, if the height's 10, that's 12 times 10, which is 120, divided by 2 is 60. So you're in the ballpark, but not quite. Brady?
11.
How'd you get that?
I divided 76 by 12, and then it was 5.5, and then I doubled it.
So I like it. So there are a couple different ways. You know, PO10 right now in algebra is working on solving equations, which we kind of have here, right? So Brady started by, you said dividing by 12?
66 divided by
Okay, so notice that 12 is in that numerator there. If you divide both sides by 12, dividing by 12 is the same as multiplying by 1/12, which is going to cancel those 12s out, right? And that left him with 5.5 equals the height divided by 2. And to get the height by itself, the opposite of dividing by 2 is multiplying by 2, right? And that's how he got to 11. Okay? So he undid the equation in the sense that he divided by 12, because that's the opposite of multiplying by 12, and then multiplied by 2, which is the opposite of dividing by 2. The other option is that if we're dividing 12h by 2, we can start by multiplying both sides by 2, which will give us 132 equals 12 times h. We could then divide both sides by 12, and that gives us a height of 11. So in class today, we talked about the fact that we had to start with that constant. We had to add or subtract first and then multiply or divide. Why are they interchangeable here? Brady divided, then multiplied. In my second example, I multiplied and then divided. Why are they interchangeable? Think of where multiplication and division are in PERMDAS. Luke?
Because like with PERMDAS, it's those two, basically whichever one comes.
It's interchangeable, right? They're the same group, same level, so it wouldn't matter which one is done first. But that's how you set it up, right? You start with the formula and then plug in what you know, okay? Let's do, let's see, the other ones are pretty straightforward, actually. That was probably the most abstract of the four here. This one. What is the area of the figure? What do we have here? Thumper? I mean, it looks like a toppled over silo, or maybe the lane of a basketball court. But what shapes are kind of a part of this? Yeah. We have a rectangle, which I'll outline in green. And we know that the formula for the area of a rectangle is base times height, so you'll need to use that. And then what other shapes do we have? Linnea. We have a semicircle. I'll highlight that in blue. What's the formula for the area of a semicircle?
Pi r squared divided by 2.
Good. Pi r squared divided by 2, because a semicircle being half of a full circle, pi r squared would give us the full circle, but we don't want that. We want half of it. So we'll divide by 2. Okay? So I think you can work your way through that a little bit. The challenge here is to find the value of that radius, you know? But there's enough information for you to find it. If you think about your math packet shaded area questions, we've kind of talked about questions similar to this here, how you can use, you know, in the other one, we used the radius to find the height and the base of the rectangle. Now we're kind of going the other way. We can use the rectangle to find the radius of the semicircle. Then the vertices of a triangle are located at 2, 1. That's point A. 3, 6. Point B, and 6, 1, point C, and you're asked to find the perimeter. What prior method or what prior concept is required here to find the perimeter of this triangle? Thumper? Side 1 plus side 2 plus side 3, but how are you going to get the length of those two diagonal sides? Evan? Use the distance formula. Use the distance formula. So that comes back a little bit. Your homework for this is to just finish the page. Nothing from the textbook for PO10. You're also going to get your practice test today. And once you have that, if you are geometried out, you'd like to go, you are free to go. But as far as recording today, we've wrapped up Unit 1. Yes, Nick? Very well. When I post this video, I'll include a question form as well if there's something else that pops up later on you want to ask about. Otherwise, that wraps me up, and that is how you math.
Don't like tag that.